So you keep hearing that Elon Musk has announced the biggest chip fab in human history, right? We're talking about a massive $119 billion megaproject called Terrafab. But what is actually happening down in Texas with Musk, Tesla, and SpaceX? Today, we're pushing past all the wild rumors and looking strictly at the verified facts, the official public filings, and the actual earnings calls.
I mean, this is the exact kind of internet claim you're probably seeing all over your feed right now. A $119 billion AI factory that's going to crush TSMC, save Intel, and power every Tesla robot and satellite out there. It sounds completely like science fiction, and honestly, most of what you're reading about it is highly distorted. But here's the thing. The reality is far more interesting than the hype, and we're about to completely deconstruct it.
Welcome back to AI Verdict, where we do the research so you don't have to. In this explainer, we're going to ground ourselves in the actual reality of Terrafab. We're going to look at the real paperwork, the true scale of the ambition, and what this genuinely means for the future of American artificial intelligence. To do that logically, we're going to walk through 6 key areas. We'll start with the reality behind the hype, unpack the vertical master plan, look at Musk's massive internal demand, dissect the Intel partnership and the packaging war, address the physical power limits and national security, and finally, we'll give you our ultimate AI verdict.
Okay, let's dive right into section 1, the reality behind the hype. Stepping away from those massive headline rumors for a second, $3 billion is the actual number we need to anchor ourselves to today. On Tesla's April 2026 earnings call, Musk himself confirmed that the immediate next step is a roughly $3 billion research fab down at Giga Texas. This pilot facility is going to have a capacity of maybe a few thousand wafers per month, and its primary purpose right now is simply to try out ideas. And this brilliantly illustrates the massive contrast between the media's empire narrative and the day-to-day reality. The headlines scream about a $119 billion world-dominating moonshot. But if you look at the actual paperwork and job listings, Tesla is actively hiring CMP engineers to polish wafers, metrology experts to measure microscopic layers, and dry etch specialists. They are hiring for the gritty, complex middle of semiconductor reality. Dirt is literally moving right now, but it's for a pilot facility, not a finished global empire. Moving on to section 2, the vertical master plan. So if it's just a pilot right now, what's the ultimate goal? Well, what makes Terrafab so fascinating isn't just its size, it's the master plan to vertically integrate the entire semiconductor stack under one roof. Think of a normal tech company kind of like a restaurant that orders ingredients from 12 different suppliers to make a single meal. Terrafab is an attempt to own the farm, the mill, the dairy, and the kitchen. Tesla's documentation reveals plans to combine logic, memory, packaging, testing, and even lithography mass production in a single facility. This creates a hyper-compressed, high-speed iteration loop where they can design, test, fix, and run chips significantly faster than the current industry standard. Let's look at why they need this in section 3, Musk's massive internal demand. Building a facility like this requires an astronomical amount of chips. This whole seed was actually planted during Tesla's 2025 annual meeting when Musk explicitly mentioned the need for a gigantic chip fab, simply because external suppliers wouldn't be able to meet their future needs. Just look at the timeline for their full self-driving and Optimus humanoid robots. Tesla's Q4 2025 update targeted the AI5 chip for production in 2027, and that is supposed to be roughly 50 times more powerful than the previous AI4. And they're already targeting AI6 for 2028. That is a wildly aggressive custom silicon roadmap that requires absolute control over manufacturing. But it's not just the cars and the robots. Look at the rest of the empire. xAI has already scaled to 200,000 GPUs, with a roadmap to hit an unbelievable 1 million GPUs by 2026. Meanwhile, over at SpaceX, they are actively hiring for advanced packaging and silicon processes for their satellites. You've got cars, massive language models, and satellites all aggressively pulling on the exact same internal chip supply. The demand case here isn't speculative at all. It's absolutely massive. Which brings us to section 4, Intel and the packaging war. To pull this off, Tesla can't do it entirely alone, and that introduces a critical partnership and a hidden hardware battle that almost everyone else ignores. You see, the real bottleneck in modern AI semiconductors is no longer just lithography. It's not just printing the smallest transistor anymore. The real fight is in advanced packaging. This means integrating compute, memory, and interconnects into highly manufacturable systems. Advanced packaging shortages are literally the reason companies like NVIDIA have been so severely supply constrained.
Terrafab is strategically positioned to own this entire integration problem, completely bypassing those external choke points. And as for the foundational compute layer, well, Musk reportedly plans to use Intel's upcoming 14A process. This node promises 15 to 20% better performance per watt, 30% higher density, and up to 35% lower power compared to their 18A node. If Terrafab becomes 14A's first major customer, it's not just a win for Musk. It would be a massive, historic validation event for American domestic manufacturing and Intel's foundry business.
But here is the crucial point: the sheer difficulty of what they're actually attempting. We like to call this the double risk stack. Risk 1 is relying on Intel to successfully ramp up an entirely unproven 14A node. Risk 2 is Musk trying to scale a massive volume fab program entirely from scratch at the exact same time. Doing either one of these things alone is incredibly hard. Doing both together, that is a monumental challenge.
Section 5, Power Limits and National Security. Even if all the technology works perfectly, we really have to zoom out and look at the massive external constraints. 10 gigawatts. That is the staggering physical constraint of power we're talking about here. Musk publicly estimates that a full-scale Terrafab would require the equivalent output of roughly 10 large nuclear reactors. The AI race right now is heavily constrained by power, land, and utilities. Terrafab sits squarely at the absolute center of these physical limitations. And the public paperwork proves they're trying to solve this at scale. Public hearing documents from Grimes County, Texas, shows SpaceX seeking tax abatements for a multi-phase fab listing $55 billion for initial phases and up to that infamous $119 billion if fully built out. To put that in perspective, if Terrafab achieved its theoretical maximum of 1 million wafers per month, it would equal roughly 71% of TSMC's entire global monthly network. But add in the fact that SpaceX's Starshield provides secure comms for the US government, and you suddenly realize Terrafab isn't just a business venture. It could become a vital, secure piece of the American strategic technology perimeter.
And finally, Section 6, the final AI verdict. Let's see how this all builds into a definitive verdict for the global AI race. If this ambitious project actually works, there are some very clear industry winners. Intel is the biggest winner by far. Right behind them are the tool vendors, companies like ASML and Applied Materials, who sell the picks and shovels of advanced fabs. The US packaging ecosystem gets a massive boost, and the state of Texas cements itself as an industrial AI hub. And what about TSMC and Samsung? Honestly, they're going to be fine in the near term. They might lose some of Musk's business at the margins, but they won't be replaced overnight.
So let's methodically break down the 3 realistic scenarios here. The base case is that Terrafab becomes a serious U.S. prototyping and packaging program, a strategic wedge and captive silicon platform for Musk's companies. The best case is that by the late 2020s, America gains a fully integrated domestic AI silicon stock spanning PARs, robots, data centers, and space. We're talking a true industrial moat. The worst case? The project burns cash, faces severe power and permitting delays, the Intel 14A node slips, and the fab permanently remains at a pilot scale while Musk is forced to keep buying from his existing partners.
The final takeaway for this explainer is exactly this. Terrafab is real enough to matter, but early enough to misunderstand. So I want to leave you with a provocative question to think about. Is Terrafab the start of a true American industrial moonshot that will completely redefine the silicon stack? Or is it an overreach into the single hardest manufacturing problem on Earth? It's a massive physical infrastructure play, and the true outcome is going to shape the global AI race for decades